Hi, now we have reached at the 7.4 subtopic, not 7 actually, this is 8. This is my old slide. I've got to change the chapter. We have add one more chapter, which is magnetic field. This is 8. Magnetic field due to current carrying wire. This is the final subchapter of the topic. Now, a current carrying wire also will give us magnetic field. Now, careful experiments show that the magnetic field B is due to long straight wire is directly proportional to the current. So B is directly proportional to the current. B, use the first right hand rule. You know the direction of B like this. If the current is in that direction. So direction of B is this one. Remember, we use the first right hand rule like this. This is your thumb. These are your fingers. They are curled like this. Okay. If the direction of your current is upward, therefore the direction of your magnetic field is like this, following the direction of the curl of your thumb. Now, directly proportional to the I and inversely proportional to the distance, R. So what is R? Okay, B is proportional to I, inversely proportional to the R. What is R? The distance of the magnetic field from the wire, this one. Distance of position, a position from the magnetic, from the center of the wire. This is the R. Any point, for example, like this. At this point, let's say this is point X. At this point, at this R, what is the magnetic field? The strength of the magnetic field. Over here, we could calculate. Okay, so B is directly proportional to the I and inversely proportional to the R. So a formula, an equation could be formed from this proportionality. So what is the equation? This is your third equation for this subchapter. So remember, B is directly proportional to I divided by R. Beer in Malay, beer. So whenever we have proportionality, we could always change it into the equation. Remember, B equals to IR. So we have a constant over here. The constant should look like this. Mu naught divided by 2 pi. See? So mu naught is the permeability of free space. You could always find the value from your calculator. Okay. If you follow your calculator, you could find the value using the constant number 33. But I have shown to you how to use the constant in one of my video. So make sure you hit the right constant number 33. You will get the value. So the SI unit of magnetic field is Tesla. Everybody knows already. Another unit sometimes used, the Gauss, rarely used. 1 Gauss equals to 10 to the power of 94 Tesla. Rarely we will use this one. The magnetic field at Earth's surface is only half G, or 0.5 times to the power of 94 Tesla. On the other hand, the field near a small magnet attached to a refrigerator may be 100 G, or 0.01 Tesla. So the Earth magnetic field is relatively small if we want to compare with a magnet that we use on our fridge. But somehow, human cannot feel this low magnitude magnetic field. But somehow, insects and birds, they are sensitive to the magnetic field. I know that some people might sense this small difference in magnetic field. But usually, the insects and some animals, especially the birds, they have the sense of the change of the magnetic field of the Earth. So if you could sense the change in magnetic field, maybe you are the direct descendants of the X-Men named Magneto. Haha, tak kelakar langsung. Now, example 6. An electric wire in the wall of a building carries a direct current of 25 ampere in that direction. 25 ampere, vertically upward. 25 ampere. Always sketch, please. Physics needs sketching. Sometimes when you sketch something, you realize that the system is not as bad. It's not as bad as represented in the sentence. It is actually a very simple system. Please sketch. From your test 2, I could see that you could not solve the question because you didn't sketch at all. Right. Now, what is the magnetic field due to this current at point P? Point P is about 10 centimeter away. It's about 0.1 meter. Now, this time I wrote it correctly. The last video, previous videos, I have stated centimeter, I have converted centimeter in meter wrongly. Okay. Now, whenever you have this kind of question, make sure you use your right hand rule. Okay. Hilang. Why? Buruk betul tangan aku. I like this. Therefore, our direction of B is like this. It is from here, moving that way, going through this one, and meet this line again. Right. Now, this is the B. We want to calculate the magnetic field, the magnitude of the magnetic field. Okay. What is the direction? Direction, we have seen it. We have determined it. It is going inside the page. This is at this point. It is going inside the page. Going inside the page. Now we just need to calculate the B equals to mu naught divided by 2 pi I divided by R. Mu naught is given from the constant of your calculator. 2 pi you could calculate from your calculator. I is given. R is given. Therefore, we could calculate B. This one. See? Using your first right hand rule. The direction of B is inside the page. Okay, inside the page. This is your B. Example 7. A typical lightning bolt produces a 100 ampere current for 0.2 seconds. Determine the magnetic field 10 meter from the lightning bolt. The lightning bolt. Shazam! Okay. Let's say the direction of I is downward. Let's say lah, kan? I downward. So the magnetic field is like this. Okay. Let's say we have a point over here. Point X. The R is 10 meter. What is the magnetic field that will be felt by the point X over here? So we use the similar equation. This one from the calculator, this one from the calculator. I is given 100 ampere, R is given 10 meter. You get this one. Simple. Exercise 6, please watch my other video I have uploaded in the playlist. Yeah? Watch in the playlist I have mentioned. Example 8. 2 parallel straight wires 10 centimeter apart. Okay. Carry currents in opposite direction. So this is the cross-sectional view. This is the first current carrying wire. Maybe we look from the top view. This is second current carrying wire. Also observe from the top view. So from the top view, we could see that the first current carrying wire, the current I1 is actually the direction is poking out from the page. The current is facing towards you. How about the second current? The symbol is X. Therefore, the direction of the current is going inside the page. This is out. This is inside. So use your right hand rule. Okay, your thumb is facing towards you for I1. Your thumb is facing towards you. Therefore, you will get the direction of your B is counterclockwise. How about the second one? Your thumb is facing inside the page. Therefore, your other finger is showing the direction of B clockwise direction. Okay. So we have I1 and I2 is given. Okay. Determine the magnitude and direction of the magnetic field halfway between the two wires. This is the halfway between two wires. The wires are separated 10 meters to each other. So halfway is 5 centimeters. So at the halfway, okay, magnetic field, the first magnetic field going here and that way. Second magnetic field going here and that way. Exactly over here, if you try to zoom in, we will see B1 like this and B2 is like this. If we zoom in them one by one. Okay, ni kalau kita zoom in mereka. So how are we going to calculate them? Calculate them one by one. Calculate B1 first. Okay, calculate B1 first. This is zoom in vision, zoom in. So B1, using the formula, straight away we will get this one. B2, we will get this one. Now, see the direction. Both are going upward. Exactly over here at the midway. Kat sini, dia sebenarnya tak nampak ni. Sebenarnya kecil sini, sana. Tapi saya zoom in supaya dia besar macam ni. Supaya nampak, oh, B1 dengan B2 duduk kat atas. So, we have this one upward. This one also upward. How are we going to add them? Just add them together lah. Because they are vectors, they have the same direction. Just add them together like that. So, we get 4.8 times 10 to the power of 95 Tesla. Right, simple as that. Exercise 7, please look at my YouTube playlist. I have other video in my YouTube playlist. I've renamed the file in exercise using the name of exercise 7. What else do we have? Exercise 8. Okay, let's do exercise 8 over here. The figure shows 4 long parallel. This is the final slide. Be happy. 4 long parallel wires. Okay, we have two cases, case A and case B, which carries equal current into or out the page. This is into, the first one is in, second in, this is out, third one is out. In which configuration? A or B is the magnetic field greater at the center of the square? We want to analyze the center of the square. Which one, which configuration of wire will have the greatest magnetic field at their center? Which one? We need to analyze one by one. Let's say the first one. Let's see the A, the first wire over here. Using your right hand rule. Your B is looked like this, because your thumb is poking inside the page. How about 2? Like this. How about 3? Outside. Like this. How about 4? Like that. And we need to analyze one by one. Okay, at that point, the magnetic field is going that-ward. Lagi mana? Yang apa? Second wire going that-ward. Fourth wire going that-ward. Third wire, the B is going that-ward. What else? And so we have left and right direction. They are going that-ward. See? Ni nampak ni. This magnetic field going that-ward. This magnetic field going that way. Therefore, cumulatively, we will have B that direction. How about this one? This B is facing that-ward. This B is facing that-ward. Therefore, this is our cumulative. Let's make a laser pointer. How about laser pointer we change to other color? Tak nampak. Oh, laser pointer always red. I cannot change the... Never mind. Okay. This B is that way. Nampak? And the B from number 4 is that way. Therefore, cumulatively, we will have this direction. Okay. What else do we have? These two magnetic field could be cancelled because one is facing upward, second one facing downward. They have similar magnetic field. Why? Because they have equal current. Atas ni tulis. They have equal current. They have similar magnetic field. Therefore, if direction is different, is opposite, we could cancel them out. How about the second one? This one also they will be cancelled out. How about the other two? They will not be cancelled out because they have cumulatively B is towards to the left. So we'll have some B at the center. How about the second configuration? Similar analysis. Okay, buat analisis yang sama. Analyze them one by one at the center. Analyze one by one the B at the center. So we'll have from number 1, we have B that way. How about number 2? How about this one? Okay, number 1 and number 2, the B is downward. Number 2, B is downward. Therefore, cumulatively, we have one B over there. How about 3 and 4? This direction. Number 3 is this direction. Upward direction. Number 4, so upward direction. We have cumulatively this one. But how about this one? Okay, wire number 4 and wire number 2 combined, they have one big to the right. What happened to number 1 and number 3? Both will produce one big B to the left. And we have to analyze one by one. These two magnetic field could be cancel out each other because they are facing opposite direction. The other two also, they will cancel out each other because opposite direction. Therefore, what is your answer? You will feel a total magnetic field at the center in configuration number 1. How about number 2? No magnetic field. They will cancel each other. That is all for chapter 8. So we have finished our chapter 8. So all the best for your final examination. Thank you.